So, HF. Anybody have the name of HF? What is the name of HF? Yes, Whitley. Hydrofluoric acid. If you said hydrogen fluoride, that's right, but the better choice is hydrofluoric acid. CaCl2, yes. Calcium chloride. Now, why is it not calcium dichloride? Because it's metal and a non-metal. Some of you guys just totally forgot about that when you were taking the test. And S4Cl5. Tetrasulfur pentachloride. Okay, why did we use prefixes? Because non-metal and non-metal. Sulfuric acid. Okay, so sulfuric goes back to sulfate, which is, hold on, SO4 with a -2 charge. All acids, they have to have what in their formula? A hydrogen. So, H2SO4. All right? Some of you, again, you just forgot that SO4 or that H is in the formulas when you see acid. Carbon tetrachloride. CCO4. And ammonium nitrate. NH4NO3.
And which one would you put in parentheses? Does it matter?
You wouldn't. You don't have to. You could just leave it like that. It doesn't matter. Also, some of you in your tests or whatever, you're putting, oh, nitrate has a negative charge, so let's put the N in here in the formula. It doesn't have a charge once it hooks up with nitrogen or with NH4. Those charges go away because they've evened each other out. So formulas, when we're doing formulas, in this unit, we should not have any charges on our compounds. All right?
Wait, shouldn't it be NO2?
Nitrate. No, that's nitrite. NO2 is nitrite. Yes? Yes, NO2 is nitrite. Okay?
Oh, it says nitrate. Or nitrite.
Okay. Any questions? And then if it would have been nitride, what would be the formula? NH4, we need 3 of them, N. Okay? All right, next. So let's get to your notes. This is Unit 7. Chemical equations and reactions. By the end of this unit, I can tell you that carbon dioxide decomposes, and you should be able to tell me what it decomposes into. All right? I can tell you that you're going to put these two compounds together, and you should be able to tell me what 2 compounds are made once you put those together. Okay? I see lots of earbuds in. They need to come out. All right, so a chemical reaction is when a substance changes its identity. All right, so the substance that changes its identity, the ones that we're going to start out with, is called a reactant. I'm going to go and bake a cake. So what ingredients do I need to make that cake? I need some eggs, some flour, some sugar, some probably baking soda, baking powder, all the stuff, eggs. Those are my reactants. That's what I'm originally starting out with. Now, what I get as a result of that, which would be the cake, is my product. So we always go from reactants, what we start with, to our products, what we end with. And I will do R and P just because it saves time writing. So what we're going to do today is we're going to be writing these equations, our reactants, and taking it all the way to the products. Now, the law of conservation of mass. This is going to be a really big deal to us starting Wednesday, but the law of conservation of mass says mass isn't lost or gained. It's just rearranged. So if I have, say, carbon and oxygen, and it makes carbon dioxide, if I start out with 8 grams of carbon and 10 grams of oxygen, then what results is I better have 18 grams of carbon dioxide. Okay? So what goes in must come out. Now, you're going to get to a point where you're going to say, oh, that doesn't look right. It's not the same thing coming in and coming out. Let me just go change that chemical formula. You can't go change the formula. We're not going to. Once you've written the formula, you leave the formula alone. And then we're going to manipulate. We're going to put some numbers here in front to manipulate the number of atoms that we have. Okay, so your homework tonight, I'm assigning 1 through 7 tonight. 8 through 13, I'm going to assign tomorrow night. So it's the same thing. You're just doing half of it today and half of it tomorrow. You can do it all tonight if you want. But what you need to know is it says, write the formula equation for each reaction. So that's what I've done here. So I have carbon plus oxygen gives me carbon dioxide. The second part of that, of your directions, says to balance the equation. I'm not going to teach you how to balance equations just yet, but you need to know, leave some space in there, like I've drawn these lines here in front, so that you know you have space in there when you're go back on Wednesday and start balancing these equations. So number 1, it's just going to look C plus O2 gives me CO2. That's all I need, right, for tomorrow, for tonight's homework. Okay, so is there any questions over that? All right, so that's your homework for tonight. So we're not going to worry about balancing. Okay, so here is some reactions, or here are some reactions, sorry. Looking at those, just take a look at it and tell me, is the law of conservation of mass demonstrated or not demonstrated? Is it demonstrated in all of them, not demonstrated at all? Or... So the first one, is it demonstrated? Okay, so this is what you're looking at right here? Just that one. That's equation 1, this is equation 2, and this is equation 3. Equation 1. We have 2 mg's and 2 mg's here. We have 2 O's here and 2 O's there. So it's good.
So if you put the mg's together, like you did the O's, would it be the same thing?
Well, mg it won't occur with like the 2 O's. Okay. So what we see, if you go down to the next one, is the next one demonstrate law of conservation of mass.
Yes. No.
I hear yeses and I hear no's. The 2 is distributed to everybody. So it's yes. Equation 2 is just a word equation or a formula equation of 1. Number 1's a drawing. I'm going to expect you to have to draw these too. Show me, draw me what's going on.
Like the 7 that you know in current affairs, you would put in like O2, and then if I had that 2 of the MG, I just put 2 of the MG.
Georgia, what was your question?
Never mind.
Okay, and then what about the third one? Yes, okay. So 48.6 plus 32 gives me 80.6, so it's demonstrated. Now, if this would have been some other number, like 90 or something, if you experimentally went in and you came out with more than what you started with, then you've contaminated something somewhere. Okay? All right. Everybody's good with that? Okay. So, there are 5 indicators that tell me whether a reaction occurred or not. You have to have at least one of these 5. You can have all of them, but you have to have at least one of them to tell me that a reaction occurred. So, evolution of heat. So, you have to have made some heat or some absence of heat. Heat's going out. So, those hot hands, okay? So hot hands, once you get them out, they're out and they're room temperature or whatever, but once you shake it and everything, it becomes hot, okay? So that's a chemical reaction involved. Light evolving, okay? So a glow stick. All right, a glow stick has 2 liquids, and they're separated by glass. When you break the glass, you get light. Okay?
Did you just say light produced?
Light produced. I put evolved, but so the production of heat or light. You can have heat and light. You can have heat, or you can just have light. Gas bubbles. If you put 2 things together and you see something start bubbling, then it's probably producing a gas, and that's a chemical reaction. We saw that in one of our labs where we put the piece of metal in the acid and it bubbled a little. A precipitate forms. So a precipitate is where we have like 2 solutions, and when we put them together, we get a solid being formed. So if you look up at this problem here, this is before. Here you have a clear solution, and you have another clear solution that's in the pipette above, and when we start putting drops of that in there, what we get is this yellow solid being formed. And then color change. All right. So we also have in that reaction a color being made. So you have to have at least one of those for a chemical reaction, for you to know a chemical reaction happened. So what happens when you boil water? Do you see some gas bubbles? Is a chemical reaction happening when you boil water?
No.
But what do we get? We get heat. We get bubbles. But are we making any new substances? No, we're just going from liquid to gas. All right? So you can have those things there, and it's not necessarily a chemical change or chemical reaction.
How would you describe a gas?
A gas bubble.
Please elaborate.
Like, so if you had, say, a solution here, all right, it's not bubbling. Oh, Alka-Seltzer.
Okay, that's how I was.
You know, Alka-Seltzer, there's a chemical reaction going on in there. Now, in your soda, there's gas in your soda, but your soda, there's no chemical reaction going on in there because your soda just has carbon dioxide pushed into it. And when you pop the lid, that carbon dioxide is able to be released. Okay? All right. So, word equations, you're going to be given a description. And description has all the fluff in there, all the details you want to know. Solid sodium oxide is added to water at room temperature and forms aqueous sodium hydroxide. So that's got all the information descriptors that you need. Now, a word equation takes all that fluff out and gets me just what I care about. Gets me to just what I care about. So, sodium oxide is added to water. Let's focus, guys. At room temperature and forms sodium hydroxide. So we've taken out all the fluff and we've put it just into the words, the ones that we care about. And that is going to help us write a formula equation. So we're going to take the words, all right, and we're going to transform them into formulas. Any questions about that?
Just like for a second.
Yeah.
So, on like our quiz slash test, we have to do that to get out the word problem.
It just depends. I haven't even really looked at it. It might just say, you know, to write the equation, the formula equation from the word. So your homework tonight is you are given the word equation, and you've got to get to the formula equation. Okay? Is sodium S?
Oh, shoot.
Okay. So here are some guidelines when you're doing this. When you start writing chemical equations. So what you're going to do is you're going to use symbols and your formulas for your compounds or elements or whatever you're doing. Symbols that you're going to see is the plus sign and the yield sign. That's what or the arrow sign. Those are the big ones we're going to use. So if you just say carbon reacts with, or if it's anything on the periodic table with some exceptions, you're just going to write it the way it is. Magnesium. What's the formula for magnesium? Mg. All right? Reacts with something. The exceptions are your diatomics. If you ever see hydrogen gas or oxygen gas or something, magnesium reacts with oxygen to produce. If it's one of your diatomics, then you need to have a 2 in it. So I bring clay for our new house. So when I say magnesium reacts with oxygen, I know it's O2. And then 2 other exceptions is sulfur. It occurs in 8s. So if I ever say sulfur reacts with oxygen, then I know it's S8 plus O2. Or say phosphorus. If I say phosphorus reacts with iodine, so I know it would be P4 and I2. So you just need to memorize that those 2, S8, P4. Then you have your diatomics, and everybody else is in their elemental form. Any questions on that? Everybody good? Huh? Those are the, yeah. Diatomic and phosphorus and sulfur. Okay. So before we begin, I told you some of the symbols we're going to use are the following. You're going to see an arrow that means it yields, makes, creates, decomposes. Okay, those are words that arrow represent. It's telling me what happened. What it started with something, and then what it turned into making. Sometimes you will see the arrow, a double-headed arrow, where, and that means, and it's written either way, it's reversible. That means it's going from reactants to products, but it's also going products to reactants. Okay, we won't do very many of those in here. Most of the time we do those in AP Chem.
Do we need to write down the subscripts?
If you don't know what those stand for, then yeah, I'll write them down. But sometimes you're going to see something that says magnesium, and it's going to have some parentheses there, subscripts, parentheses with an S in there. The S means it's solid. If there's an L, it means it's liquid. If there's a G, that means gas. If there's an AQ, then that means it's aqueous, which means it's dissolved in water. All right?
That changed the equation anyway.
No, it's just more information in there. Okay? And that, I mean, it tells me a lot. If I gave you a reaction here, or not a reaction, but something like this, then you can tell me that, what did I do? I boiled it, okay? Questions? Y'all ready to go do some of these? All right, let's go practice. Before we practice, let me say this real quick. I can write equations all day long, but equations, there are things that can't tell me. Equations can't tell me if the reaction will occur. So I can write an equation, and just by looking at it, I can't say that that reaction is going to occur. I have to think about how much energy everything has, and if I need to add energy or anything else. It can't tell you how fast the reaction is going to go. Is the reaction going to be immediate? Is the reaction going to be very, very slow? That all depends on kinetics and some mathematical equations. And then it won't tell me how does this change? How do the bonds change? So those are things you can't get out from a formula.
Do you need to know why, or do you just need to know?
You can just know. So we don't know if it'll occur, we don't know how fast it'll occur, and we don't know what happens to the bonds. Okay. You have your description. The description. We're going to take all the description, or all the fluff out, and we're going to get our word equation. And then we're going to take our word equation, and we're going to make a formula equation. So, solid sodium oxide. Sodium oxide is added to water, and it forms sodium hydroxide. So now we're ready to write the formula. What's the formula for sodium oxide? Na2O, I hear? Na2O. Sodium is a +2, oxygen is a -1. That means I need, blah, blah, blah. Sodium is a +1, oxygen is a -2. So that means I need 2 sodiums for every 1 oxygen.
So the diatomic thing, that's all when it's by itself.
By itself, yes. Plus water. Formula for water? H2O. Gives me sodium hydroxide. Sodium has a +1. Hydroxide is a -1. So what's the formula? NaOH. Again, these are not balanced. I'm not demonstrating the law of conservation of mass right now. I just want to get through the formulas.
We don't do that until Wednesday.
Hmm?
We don't do that until Wednesday.
Wednesday. Questions on that one? Everybody good? Okay. I'm going to be lazy here. Zinc metal. So word equation, we just want to take all the fluff out. So we want zinc is added to hydrochloric acid to create zinc chloride and hydrogen. Okay? Put that into a formula. What's the formula for zinc? Zn. What is the state of matter of zinc?
Solid.
It's a solid because it says it's a metal. Is added to aqueous hydrochloric acid. What's the formula for hydrochloric acid? HCl, and it's aqueous. We get zinc chloride. So now we need to find out what the formula for zinc chloride is. Zinc is a +2. Chlorine is a -1. ZnCl2. And it is aqueous.
Does it matter if we put that in the thing, like it says in the sentence?
You can, but you don't have to. And hydrogen gas formula. H2. Again, these are not balanced, so. Huh? That's all we're going to do right now. We're going to leave it alone. So let's do, y'all ready to do some more practice? Yes? No? I want to tell you, like when we talk about H2SO4, I know I probably said this, but H2SO4, that's the formula. You don't go because SO4 has that -2, you don't put that in there. No charges at all in our formulas. Solid calcium. So I'm going to pick out my key words. Calcium reacts water to form calcium hydroxide and hydrogen gas. So what's the formula for calcium? Ca. And what's its state?
Solid.
Solid. And it reacts with water. What? I'm going to assume that it's liquid water. To make calcium hydroxide. Calcium's a +2, hydroxide's -1. So what's the formula? CaOH2 and hydrogen gas. H2. Everybody good? We're going to do one more and then I'm done. Let's see. All right. So my word equation is copper reacts with silver nitrate to produce silver and copper 2 nitrate. So what's the formula? What's the formula for copper? Cu. And it reacts with silver nitrate. So silver is Ag with a +1. Nitrate is NO3 with a -1. So the formula for silver nitrate is AgNO3. Maya, put it away. To produce silver metal. Oh, so I'm skipping the states of matter. I'm just not putting them in there. You can put them in there if you want. So what's the formula for silver? A is Ag plus copper 2 nitrate. Copper tells me it's a 2 plus, and nitrate is a negative.
1.
So
NO3 2.
CuNO3 2. One of the things I've been seeing is people will say, oh, because it's copper 2, I've got to put a 2 there. No. All right? I saw some of you guys putting formula or putting, you would say Cu2 NO3. Again, you can't do that. You can't put Roman numerals in there. All right, yes, question. No, it doesn't. It doesn't matter. If you put copper nitrate and then silver, that's fine. That's the same thing. Okay? Any other questions? All right, so your homework is 1 through 7.